Hi, my name is Guilherme Preis, and I'll be presenting today on a study about Senecavirus A, which is the causative agent of a vesicular disease in pigs. The title of the presentation is The Detection of Senecavirus A and IgG Antibodies Over Time After an Outbreak in a Breeding Herd. As mentioned, Senecavirus A causes a vesicular disease, and it is very similar to extremely important foreign animal diseases such as foot and mouth disease. So Senecavirus actually brings a great concern on its potential to create confusion in the event of a true introduction of foot and mouth disease in the US swine herd. This was a preliminary longitudinal study, and it was performed in a 6,000 sow farrow to wean herd that was conveniently selected after going through an outbreak. We randomly selected a cohort of 60 sows, and we did monthly IFA testing by monthly collections of serum from these animals. We also did weekly RT-qPCR testing of processing fluids when we were looking for viral RNA. The processing fluids, for those who are not familiar, they are described as the serosanguinous fluid that is recovered at the time of castration and tail docking of young piglets. RT-qPCR testing was also performed in oral fluids from on-site gilts, and we were trying to assess how far could this virus spread inside a farm, since these gilts, they were actually located in a different barn inside this farm. The oral fluids were collected by suspending cotton ropes in an area of the pen that was accessible to all pigs within that pen. The rope was then left inside the pen for 30 minutes so animals could chew on it, and the extraction of the oral fluids was done afterwards. Going to the results, out of the 60 sows that we followed over this period of over 1 year, 59 of them were positive, which is pretty interesting because it shows that this virus can spread a lot within a herd, and this can actually also be seen by the number of animals that show clinical signs during an outbreak. The length of IgG detection by IFA is then at least 58 weeks, which was the period of time that we were able to follow these sows, which shows us that this tool of IFA can be a very good tool for monitoring of Senecavirus and can really tell if our farm has had contact with this virus before. Now, perhaps the most interesting results from this study was that when looking for RNA in processing fluids, we were able to detect it 11 days before and 54 days after the outbreak. And we can see this here in this graph on day 0. So this was the day of the detection of the outbreak. That was when the farm workers and the veterinarians saw the first signs. And when we tested processing fluids that were stored, we saw that 11 days before we had pretty high CT values, but they were already positive. So this means that we started with a low amount of viral RNA copies, but at the time of the outbreak, we had CT values pretty low on the 17 or 18 range, which means that we had a lot of RNA copies right at the time of the outbreak when the clinical signs started. And the CT values started constantly increasing with the last time point of detection being 54 days after. So this is also very important because processing fluids are commonly collected in farms all over the US for monitoring of other diseases, and this shows us that this can actually also probably be used for monitoring of Senecavirus, which can help us prevent the spread of the disease between herds. Going to the RNA that was detected in oral fluids in the gilts that were situated in different barn, we were able to detect it 47 days after the outbreak, which also tells us that this virus is really going far inside this farm, and might also be used as a tool for detection of circulating virus. Now, very exciting and very important, with this preliminary data that we generated, we were able to write a grant, which was then awarded by the American Association of Swine Veterinarians, and which means that right at this moment, we have multiple farms being followed on another project that is very similar to this one that is being presented, so we can further assess and evaluate the use of these tools for monitoring Senecavirus A in pigs. With that, I would like to thank the University of Minnesota, the College of Veterinary Medicine, and Carthage for providing us with the samples and the farm. Thank you for your time.